Thank you and welcome to FCA International's March Safety Call. The purpose of these calls is to provide information and work to create a community of safety professionals in the signatory finishing industry. Earlier this month, FCA wrapped up its Crest Safety Awards contest and announced winners at the 2026 Signatory Contractors Conference in Scottsdale, Arizona. Winners and top finishers will be receiving their awards, marketing materials, and certificates shortly. Also, FCA recently expanded its quality assurance program to include flooring and flooring materials. And FCA safety products can be requested from the FCA safety resources page at finishingcontractors.org or email us at safetyhelpline@finishingcontractors.org. And now we welcome our guest presenter, Alex Zavan, a safety professional with OnPoint. Thanks for being with us today, Alex.
Hey, thank you very much, and thanks for having me. I definitely want to thank you for your time. And as you know, this is a recorded video that you can reference as we allow you guys to have that link when you get that from John there. But I want to just basically highlight the topic, which is something I want to share. Let me grab my screen. And can you see my screen, John?
Yes, I can.
Okay, here we go. Well, this is the monthly safety call, and it's electrical safety and construction. I just want to say again, welcome. And this is one of the most persistent and deadly hazards that anybody can really experience. It's not just workers. It's in every task we do. It's everything we touch in the morning as we get ready. But when we're talking about what this specifically could be related to your field and what you might see out in the sites that you look at for safety hazards, we look at things like lighting tools, heavy equipment. If we do operate those, temporary power, anything that we're setting up, and a lot of people have had close calls, and there's going to be some stories that I'm going to kind of highlight on this presentation to kind of bring it a little bit more closer to home. I also want to say that OSHA consistently ranks these electrical hazards among some of the top fatal injuries in construction. And as we'll see, some of these fatalities, are just life changing. Obviously, if anything were to happen while out in the field, it would change your life dramatically. But we just want to make sure that as we go through this presentation, you do, if you want to participate just on your own when the quizzes come up. I've thrown some quizzes in there to see if we can just kind of test our knowledge. And we're going to talk about general hazards, controls that we can use, arc flashes, temporary power setup, different types of real scenarios, and some good takeaways. So I want to share that the FCA Safety Line is an excellent resource for what we call templates, health and safety manuals. There's a lot of good resources, and I'm going to reference some of the toolbox talks in the following slides. And it's a great place if you have any kind of questions. If you have an incident or something happened, or you got a question about a contractor, subcontractor, just use that number right there, and someone will respond to you. Make sure that you get a screenshot of that or write down that number so that you can reference it. But why does this slide really matter? It's just that there's a lot of changes happening to keep contractors compliant, competitive, and we want to try to basically help support that through the FCA Safety Line and make sure that you guys out there have a resource that you can use. So let's just talk a little bit about what we have here in this slide. We pretty much know the components of electricity, what it is, and how you actually can rate it through volts, ohms, and amps. And there's the definitions there. We know what they are primarily. Some electrical exposures that we kind of come across in our fields as we're out there is generators, working in wet environments, very common. Defective tools and equipment. We see oftentimes cords that may not be properly functioning or missing ground plugs or ground prongs that are needed. But we look at lighting, we look at things, even overhead and underground power lines, but don't forget it can be lines that are energized even under the flooring system or in walls that we can't see. So we always have to make sure that we're looking for these things and identifying them before we start working around them. So we look at some of these other ideas of different type of like telehandlers that we may use if we're moving different drywall or things. We have to look above and around and making sure that we don't hit or contact some of those power lines that may be overhead. So start looking at some of these things as we start to work in the field, and if we do see these hazards, we want to point them out and change the behavior so that no one gets hurt. So some of the hazards for worker safety are exposure to electrical energy, secondary injuries, which could be falling off of a ladder, which I'll share some stories as we move along. Electrical shock, electrocution, which actually is death. Shock is different than electrocution, burns and falls. And what we want to do is protect ourselves with proper PPE, GFCIs, and make sure that we understand that even using low voltage energy, and if we work around that, can also be hazardous as well. But we want to make sure that we are using the best means possible to actually avoid shocks and some of these hazards. So there are some other recommendations for digging around utilities, which may not apply for your field, but always make sure you respect the distance of these energized lines that we may come in contact with. Again, electrocution, some of those definitions across the brain, chest, muscle contractions. We'll take a look at some of these milliamperages that can actually cause those. The impact, always remember it's current, path, and time. Current is always the stronger. The electrical current is the greater likelihood of injury. And the path that it travels through your body can have a huge impact on whether or not you survive. And then, of course, the longer that you're exposed to that can also be hazardous and almost fatal in most cases if it lingers and you can't break free from that energy. And then prevention, keep electrical equipment and extension cords in good condition. And how many times do we come across electric cords that either need repair or have been repaired and need professional assistance in getting them repaired? Inspect them always, make sure that we watch out for electrical hazards when working overhead. But remember, it's even overhead live electric, which we'll see in some of the pictures that we have later in the presentation. Check your tools and always use ground fault circuit interrupters. Very, very important when we're working near moisture or water. And these are things that can protect us. So electrical cords, we pretty much know what we just talked about, making sure that these are in good condition. Always inspect them for frayed wires or GFCI damage or any type of prongs that may be missing, and replace them and pull them out of service as needed. And then never use damaged cords, utilize the ground fault like we talked about, and never pull on the cord and try to lift that tool because that can weaken the cord system and actually cause it to separate and could definitely cause a grounding problem if we come in contact with it. Always unplug cords from the end of the plug. Don't pull on the cord to get it released from the socket. Then we talk about some of these other electrical power, temporary powers. Always make sure that your generators are GFCI rated. And a key thing when we are working with generators, we want to make sure that we're watching the carbon monoxide production. Very, very important that we make sure that we have set it up properly. It's also recommended that sometimes we get a carbon monoxide detector to see if our air is well ventilated and we are not going to encounter the side effects of carbon monoxide, which is odorless and can just basically be fatal. So we have to make sure that we're monitoring that and have good ventilation. And then worker safety, again, comes back to that GFCI, and also well insulated cordage. We also want to be double insulated if we are using power tools as well. That's just another option we'll talk about. So temporary power is oftentimes needed but not used. Sometimes we'll come across sites that have electrical cords that are daisy chained or connected to one another, and want to make sure that we use this temporary power properly. And we'll get into some of this as we move through this, but want to make sure that these temporary powers have pretty much a dedicated breaker if we can connect them to them. We don't want to run our whole operation off of one temporary power and kind of short circuit or overload the system. So temporary powers are very, very important, but they have to be set up properly, stable, on make sure that we're not having any type of open conduit or any type of junctions that would expose the wires, and our gang boxes have to be covered as well. But some of these hazards, as we already talked about, we want to make sure our cords are well maintained, that we don't have a trip hazard that could cause a slip and fall, which is very common, or we don't want to have motorized scissor lifts running over these cords and weakening their structure. So again, just watch for these things and always be careful that the cables, as we talked about, and make sure that we're not exposing these temporary power stations in the wind and rain. Make sure we have some covering for that, because we do not want to have moisture affect these and create another hazard. So fall protection really is not the focus necessarily in this presentation, but we do want to make sure that trips, slips, and falls are always addressed. Very common in the workplace. And I think the most important thing that we can focus on at this point is making sure that our pathways, keeping walking pathways, including stairways, clear of trip hazards, making sure our cords or anything that we could possibly trip over is cleaned up so that our workers are safe. So we're going to move on. So again, arc flash is something we're going to be talking about briefly. We're not going to get into too much depth with the details, but it's one of the most severe electrical hazards in construction. And the recent OSHA updates emphasize that even low voltage is also important to watch out for. That can generate arc flash energy, which is incredible. And we'll show a video of what that looks like. But even systems with low voltage of 120, 208 volts can be catastrophic to resulting in burns, and we underestimate the power of this event. There's new standards that are coming out in 2025. They did come out that are tightening the expectations around data collection around this event called arc flash, and really they're tightening down on correct PPE and who can be around live energy, who can work around it, what the limits are. We'll show you a little bit of that so you can understand that. But these updates reflect the continued trends that electrical incidents are just totally unexpected explosions, and it can happen in a second and in milliseconds, and it can be just life-changing, if not fatal. So again, here we talk about fatalities. We have groups of, industries, different types of construction and extraction. We have management, we have transportation. You can see some of these electrical fatalities by exposure. This is a 2019 study. And there were 166 electrical deaths noted in this study. And while annual numbers still fluctuate, the national data still shows electrical fatalities remaining consistently high. And it's interesting that 74% of the workplace electrical deaths occur in non-electrical occupations. So you don't have to be doing electrical work as an electrician to experience this. And there's an increase here shown in this study, 3.75 from 2018 to 2019. So a lot of these are hidden and unexpected energy events, and it's happening with people who are not the workers. It's silent, there's no noise, there's no warning, and no second chances. So understanding again how that current path and exposure time affects everything, and there will be a couple stories that I'll share with you concerning this. So again, low voltage. This is something that is something that needs to be expressed, because we can't think just because it's low voltage that this cannot affect us. So one of the things that make low voltage very, very dangerous is that when we have a lowered resistance in our body, or we're sweaty or wet, this allows the low voltage system to deliver lethal currents through our body. So the story goes that there was a cleanup crew performing work inside a renovation area, and they were using 24 to 30 volt LED temporary lighting system powered down by a step down transformer. And one worker noticed condensation on the fixture, but assumed it wasn't a risk because the voltage was low. When he adjusted the light, his wet gloves created a conductive path. The current passed hand to arm, causing involuntary muscle contraction and knocking him backwards off a short ladder. So falls can be a secondary incident to a primary incident like this one shown in this case. So although he survived, he suffered nerve damage in his hand. The incident investigation confirmed that the same principle shown on this slide, the low voltage doesn't mean low danger. So current, not voltage, determines the severity of the injury. So understand that even 30 volts can be deadly. This can help us understand and transmit this information to our workers and make sure that they understand. Always make sure, if you can de-energize, do it. You have to make sure everything is not live when you're working around this stuff. So here's a quiz. You can take a moment and actually write this down, or you can choose to chat in the next, if you'd like to just chat over the right question. But here's a quiz break. What three factors determine how severely electricity can injure a worker? And I'll give you a second there, but it would be, correct answer would be B, current, path, and time. Electrical exposure as low as, what would that be? Again, we talked about 30 volts, low voltage, can be fatal. And most electrical fatalities occur among which group of workers? And we talked about non-electrical workers performing routine tasks. That would be answer D. So what actually causes fatalities during an electrical contact? What actually causes the fatal injury during electrical contact? That would be amperage and exposure time. So electrical hazards can kill in multiple ways. There's this acronym that we're going to use: B for burns, E for electrocution. Remember, that is fatal death. That is it. Shock is when we can get away from that and we feel it and we can pull back and get away from the actual source of electricity. And then the arc flash blast, which we kind of introduced, we'll kind of take a look at that in a few minutes. And then we also have fires and explosions. So if you think of Be Safe, these are your acronyms. And what does kill? And that's the question. What kills? Volt, amps, or ohms? And remember, it's not the voltage number that matter. It's the total energy involved. Amps, exposure time, and the path through the body determine the deadly contact, like we saw with the triangle. And these are the things we have to always keep in mind. So interestingly enough, electrical hazards can compound the incident. So like a shock can cause a fall, an arc blast can cause burns and blindness, which we'll see in a video, And an arc blast can rupture your eardrums or your lungs because of the percussive effect. And also, contact with energized parts can stop the heart in milliseconds. So, electrical energy is unforgiving, and there's never just one way. It does hurt you. And we'll kind of work on some stories as I can show you that. The most common sources of electrical exposures on job sites, electrical systems, and equipment. These are some of these sources of exposure. Electrical systems and equipment, overhead and underground, but remember, it can be anything under a floor or a wall. Power tools and extension cords that they're not properly maintained or inspected. Improper use of a tool, and lighting, and in the environment itself. So we have to take a look at these uh, before we actually get to work and make sure we minimize them. But these are everyday situations where workers let their guard down because we think a lot of times this is just routine. We'll just work around that hazard. So here's a practical story of a finishing crew that was working in a partially lit renovation area using several extension cords daisy chained together to power multiple tools. One cord had been taped from a previous repair, and that's where we have to get a qualified person to look at these cords rather than just try to tape them up. But this cord had been taped from a previous repair and was laying across a damp section of the floor. And when a worker stepped on the tape section while adjusting a light, the compromised insulation allowed current to pass through the wet surface into his boot. The shock wasn't severe enough to knock him out, but it caused a violent muscle reaction that made him fall backwards and onto stacked material, bruising his ribs. Basically, damaged extension cords were a cause, improved the repairs that were not done right, and a wet environment all led to this outcome. So electrical exposures come from normal equipment in normal conditions, tools, cords, poor lighting, and the environmental moisture. The assumption is that these hazards are low risk because they exist in the workplace, and we have to really get past the complacency, and we have to look at what can we do to minimize before we actually start the work. And here's some examples of some overhead, underground. These are the most dangerous electrical exposures we can see on a job site. But keep in mind, again, if you're working inside an old house, you have wiring that can be placed there years ago, and you don't know exactly what's live or what's hidden under the flooring or in the walls. So always make sure you're looking for that. And anytime you unload or take material off, always look around if you're outside unloading those materials that you're not near any type of energized power lines. Very, very, very important that we take a look around and not think these are just repetitive tasks that we can just do. Always make sure someone is spotting you, making sure someone is guiding you away from any type of hazard if you are using mechanical machinery to unload that. So some of the most common on-site electrical hazards. So we have exposed parts, we have defective cords, we talked about that. We have defective tools we come across, we see these on site, they need to be inspected and removed if needed. And then we have, of course, improper use of cords and how we stabilize them. And we have improper or damaged installation. So someone before may have come and not properly connected the wiring and the protective conduit. And then we have lighting that can also be a problem. So this is another story. A painting crew was working during a renovation where several temporary lights had been installed. One fixture had a missing cover, leaving exposed energized parts inside the socket. Poor lighting made the defect hard to see. A worker went to reposition the fixture, assuming it was cool and safe to touch. When his hand slipped inside the housing, he contacted the energized metal base. The shock caused him to jerk backwards, fall from a short step stool, and injure his wrist. The investigation identified multiple hazards, which were exposed parts, poor lighting, damaged fixture, and assumption that everything was normal. So this is why it matters. These aren't just electrician hazards. These can happen in our homes. We can all make the same mistake by thinking things are just normal. But our workers need to recognize that they have to check things out themselves, make sure they're checking before they actually touch or utilize. So here's an interesting slide showing some of the amperage that can give this symptoms. Uh, so let's just look at this. It's 1/1000th of an amp giving a tingling sensation. And then we go up, mild shock, tingle pain. We might have all felt that at one time. And then the GFCI trips somewhere in the 4 to 6 milliamp. And then as we go up, obviously it gets harder. Can't let go unless we become free of that energy source. And then muscle contractions set in. And as we keep going up, then the lungs start being affected where we can't breathe. And then the heartbeat stops. And then the breathing stops. And we can go all the way up to 1 amp. So you can see the GFCI is very, very important, plays a very, very important role of protecting people. The breaker will protect the actual equipment, but the GFCI protects people. So as we look at this here, if we add 14 more amps, then the circuit breaker will trip if we have something along the 15 amp breaker. But this is why it's so important to look at the GFCI and use it routinely when we set up our workstations. So here it is. They protect people. The GFCI senses a fault to ground, usually around the 4 to 6 milliamp, and it does trip within 1/20th or 1/5 of a second. So it can actually save lives. We want to make sure that we use these properly and don't try to bypass the GFCI system. So they're very, very, very important. Make sure that we take a look at those when we're out inspecting sites as well. So 3 key protections for our electrical plugs. We have a grounded plug. Handheld tools are used mainly with this. We see a 3-wire plug. Then we have double insulated. So that is the second protection control that we have. And then the last, again, as we talked about with the ground fault circuit interruption, very, very important that we always think about this and actually use them at the source. We never want to take this GFCI pigtail and move it away from the source. We want to connect it to the closest available source that we can, rather than bypass that and connect it down the road. So here's some more quizzes. GFCI and tool protection. Let's talk about that. A GFCI protects which of the following? And would be C, people. And then we have GFCI typically trips at, we talked about this, 4 to 6 milliamps. So I'm just letting you take a moment, see if you can get these right. Double insulated tools contain 2 protective insulation layers instead of a grounded housing. So you will not see the actual ground plug on that. It'll be 2 protective insulated layers. So here we go. We're looking at dead fronts on the panels. These are very important. A lot of times, if debris, different types of constructive material, could be even metal, can get in behind some of these boxes. And basically, if you have any contact with it with a metal tool or any type of energized parts that have been, not cleaned out or are susceptible for grounding, you can actually be involved in a pretty serious situation here. These controls, these covers, these protected conductors, and making sure everything is clean and accessible, these controls prevent the accidental contact with energized parts. And it's very important to understand these boxes are very, very dangerous. and we take them for granted oftentimes. And we want to make sure that we make sure our workers know that these are to be respected and make sure that they are taken care of on the work site. Panels, again, electrical panels must have all the following except, and the answer would be D, decorative covers. We don't need any of that, but we have to keep the other ones intact. And the panel label, if it's missing, treat that equipment as high hazard until assessed. Do not assume that that is a de-energized panel. And before using any tools and temporary equipments, workers must conduct an inspection for any damage and defects. And that is very important. That's before using any tools and temporary equipment, or the power sources must make sure that is checked out for any type of problems. So lockout tagout is one of the most essential safety procedures for preventing severe injuries when working on or near. Now, when permissible, we'll always lockout tagout with a qualified person. Tagging and labeling is very important when you are working in an environment, and making sure that at the breakers you designate what's live, what's not live. Always make sure that you communicate to people, through a qualified source of identification to make sure that everyone knows which circuit is alive, and never assume that just because that breaker's off, you always want to make sure you test and make sure you check with that qualified person for validation. So the left-hand rule is something that we use. We'll see this in a slide here, but you do use a left-hand rule when turning off a disconnect. And you want to make sure that the operating disconnect and breakers, to avoid being in front of it. We'll show you a picture. If not, the picture just shows using your left hand and standing away from the actual energy source as you disconnect. Lockout tagout must always be performed at the source breaker. Always make sure you go back to the source where the energy is coming from. And before touching equipment, after lockout tagout, you must test for zero energy. Always make sure that it is not alive and before you do your work. So here's your arc flash, and this is what we're moving towards the end of our presentation, but arc flash does need to be explained. Arc flash is the explosive release of energy caused by an electrical arc, either phase to phase or phase to ground. So this temperature can be very, very hot. So as you can see, temperatures can rise well into the 35,000 Fahrenheit. And there is also percussive waves, explosions, molten metal, shrapnel, intense light. There's a lot of things happening that can be very, very, very dangerous. So this is something that is being explored or watched to make sure that people in the field learn to wear the proper PPE, stand away, prepare themselves. And as you can see, the blast was just intense from contact and grounding out that area. So here are some examples of 3 different critical distances. The first is the arc flash boundary. And these are determined based on engineering with a label that's placed on the electrical source to make sure that the individuals working in this area know what the distance is and what PPE to wear. And it explains a lot about what you could expect if there were an explosion. But the first one is the arc flash boundary, and the next one is the limited approach boundary, and the other one is the restricted boundary. So the arc flash boundary is where a worker without proper PPE could receive a second-degree burn. The limited approach boundary is in the next area, and that's where an electrical shock hazard exists, and only qualified people are allowed to be in this area. Restricted approach boundary is only that is where the qualified. This would have to be someone who is allowed in that area, the restricted uh, approach is the qualified worker. I apologize. The limited approach boundary, you still have to have qualifications to be in there. You would not allow just anybody to cross that barrier without knowing what they're doing and why they're there. So these are the three areas. Want to make sure that we respect these areas and always understand that arc flash is a very, very dangerous thing. This is the left-hand rule we were talking about. The left-hand rule applies for all disconnects and breakers, path position. Make sure you stand off to the side and turn away before pulling the switch. So here is something, this is the wrong way of doing it, and this is the right way to do it. Always make sure you turn away. An arc flash, again, if we were listening, what would be the answer to this one? It would be the arc flash boundary would be the distance at which a worker without PPE could receive a second-degree burn. Now, again, the qualified workers with insulated tools may enter which one of these? This is the restricted. So again, I was talking about the qualified worker with tools. That's that second boundary called the restrictive. And then the temporary power must be grounded and GFCI protected. So again, we're talking about temporary power. Always make sure, again, the GFCI is going to save the person. Very, very important. We always use that. And then which of the following is not a major type of electrical hazard? Obviously noise, the one in D. And the temperature, again, for an arc flash, remember, it was 35,000 D. So here's some pictures that might come in handy just to kind of see what we're dealing with when we do some site inspections. We're looking at some wiring, some cordage that is kind of just balled up there. And there another cord to the left, if you can see that over to the left. This is not a well-maintained electrical cord situation. And then we have moving equipment that could easily run over these cords, weakening their structure, puncturing them, wearing them out. And again, workers taking it for granted, they just grab that cord that may be generating live current and just find themselves grounded in a very bad situation. Here's an example of temporary power. We can see that it's set up. We do have cords, though, at the bottom that are not well maintained. They do not look like they are, in a good position for trip hazards. So we need to make sure that we are keeping that area for our cordage very safely out of the way. Always label, always have a qualified person obviously come in, label what is hot, what is not, but you have to be clear about that. And if you have any questions, you need to work with that qualified person to make sure that they are properly labeling. Here we have a box, we're kind of looking at it, and what is hot, what is not, we don't know. So we definitely want to make sure we go back to the source and make sure that we understand which breaker is alive as we're dealing with the work site. So again, we wouldn't want to just walk up and touch this without knowing exactly what's happening to it. If it's live, we'd have to test, and we'd have to go back to the source to make sure that we have that properly shut off and desourced. Again, these are other types of hazard, whether you paint them red, whether you paint them blue, there has to be proper communication to know exactly what is hot, what is not. And here's some additional coloring. Again, there has to be really good communication to understand what's going on here. You would not want to reach for any of these wires. So again, at work sites, we need to make sure we understand where the source is and how we're testing, who the qualified person is, what we're touching, and making sure our employees are safe and understand, everything from live electricity to cords that we don't take care of that could hurt them. When we're working with temporary alternative power, we want to make sure our generators are GFCI. Again, remember, GFCI protects the person, and we want to make sure we go to the source. So if we had a pigtail, we'd want to put the pigtail here. Here's just a cord running through a doorway, making sure that we have proper cord placement. That door is going to wear down that cord. Again, if an employee picks that up while it's still energized, there's going to be issues. And also the housekeeping needs to be in order as well. Here's an example of a kind of a splice, highly not recommended. It would have to be done by a qualified person, but the knot basically there prevents pulling of the cords apart. So that is a somewhat of a properly tied knot, so that we would have minimal separation if it were tugged on either side. But make sure that we don't daisy chain, use some of the other processes of temporary trees, power trees and things that we've seen. Here's a cord that's just dangling, not a good practice. We want to make sure that we use the correct way of transmitting the cords through proper hangers and not just use the metal that you see there. Here's a good shot of an open gang box with not a properly tied knot there. As you can see, that could still be pulled apart. We have exposed wiring. We don't know if that's live or not. Even if someone does tell us that, yeah, that's turned off at the breaker, we don't know what that is without testing. So we want to make sure that we're looking at all of this. We don't want tools or any type of metal contact going inside that gang box. Not a good situation here. We want to make sure that that is not repeated. And here's a beautiful example of what not to do. If you look at the electrical outlets on the actual bottom there, you can see that it's allowed for 5 different outlets. However, this 6-prong circular outlet is plugged into one without a grounded plug prong. And we want to make sure that we're not repeating that situation. Not a good setup. And again, here it is. And then we want to make sure that we keep our cords well maintained and out of the way, and so they do not become damaged. But again, I appreciate the time. Again, this is the helpline. If you do have any questions at any time, or you run into a situation or want to use a template that you have available to you, this is the help FCA safety line, and be happy to take care of any questions that you may have. And again, appreciate your time.
All right. Great stuff today, Alex. If anybody does have any questions, feel free to unmute or throw them in the chat. If not, just want to say that was great. Certainly lots to consider, as always, when it comes to this topic. And I thought the point with low voltage doesn't mean low risk. I think that's a important one to remember. And I really enjoyed all the great quiz questions as well. I think that could really help out a lot of contractors.
I do have a question if you got a second.
Please. Yes, please.
Yeah. Just working around power lines, that 10-foot distance. What can a contractor do when the owner just can't or won't de-energize? It's a bank, it's a stock market, whatever it is. We bid the paint, we got the job, we find out after there's power lines coming into the building that look like spaghetti. So we call ComEd, they will come out and insulate them, thoroughly. But if you have to paint that, call it brick wall right there, what is a contractor supposed to do?
Now, I'm not going to say that I have all the answers, but I do know that there's ways to actually insulate those wires through, I believe there's some sort of insulating blankets that I believe can be thrown over those. Now, I don't know exactly what can be done. Rich, if you got any ideas, let me know. But I have not been in that situation.
Yeah, so that's the sticky wicket that subcontractors often face. Whose responsibility is it? So the subcontractor, of course, has a responsibility to protect the safety and health and welfare of their workers, whether the general contractor cooperates or not. And this is where you get into that, you know, are we going to stand up and tell the general contractor we are not going to work in this area until you make it safe? Because this is outside of your scope and it is his building. You could argue and say, make sure you use non-conductive painting poles if you're using, you know, brushes and rollers. But if you're
Yeah.
spraying, you're going to have to get into proximity. And there has to be a good working relationship with the general contractor. Frankly, the time to address this issue is in the planning and the bidding phase, so that it is well spelled out in any contracts that in the area that you're working where there is exposure to electrical energy, that the energy will be de-energized, rerouted, or shielded. And only a qualified electrician, generally the power company for the source lines into the building, can do that. You can't just grab some big yellow blankets and throw them over the cable while you're there. You're exposing your workers to risk of electrical exposure while you're doing that. So this is difficult. This is often overlooked in the planning phase and in the bidding phase. And you know, not to add too much to stories, but I was just telling Alex earlier today, subcontractor recognized a fall hazard by an open elevator shaft, advised the general contractor, hey, we have an open elevator shaft here. We need guardrails put up. And then they proceeded to work on that floor. Now you're looking at a 300, 400 foot long building. They're running electric, roughing in electric from one end to the other. Near the end of the day, the guy on the ladder says, I was pushing wire in. I saw the other guy pulling the wire back. I pushed some more wire in. I looked and he was gone. And the guy had backed right through the open elevator shaft and fallen a floor and a half down below. No significant injury, but he's an older guy. He was out for the season. You know, no broken bones, no busted head, nothing like that. But this was our client, and our client wanted us to do an investigation and hold the general contractor responsible for not protecting that opening after they were informed. And we had to advise them, you were aware of the hazard. You brought it up to the general contractor. Okay, great. So far, so good. Then you went ahead and worked in that area without implementing any corrective measures of your own. You did not put up any barriers to prevent you from getting to that opening. You did not put up guardrails. So you're going to own at least 51% of the responsibility for that worker's injuries. So same thing with that electric. You have a choice. Am I going to work in this hazardous condition? The correct answer would be no, I am not. And if you are, understand that even if you inform the general contractor, hey, those power lines need to be shielded and covered, it's tough, you know, because you have deadlines too. You have, you know, costs involved by holding off on work stoppages. But I wish there was a good answer other than work it out with the general contractor and make sure that's protected.
Yeah, and protection though, when ComEd sleeves them or blankets them, they from what I understand, that they have told us, hey, we blanket them, we shield them, you still can't work within 10 feet. Then I'm like, what's the use of blanketing or shielding them then? And they say you still can't encroach. So is it that you can encroach if you have not your body, but if like say your body's 10 feet and you have an extension pole that's non-conductive, is that OSHA compliant?
So most of the distance requirements are related to cranes and heavy equipment. There is a requirement under scaffolding where they say that if you have insulated lines and it's less than 300 volts, you can be 3 feet away. If they're insulated lines and the line voltage is between 300 volts and 50,000 volts, you have to be 10 feet away. So that's under the scaffold standard. Many of the buildings that you're working at, the lines coming in are 480, 640. I mean, there's a lot of voltage in there. So for household, 110, 220, you're probably okay. Anything above that, you're starting to run into excessive juice. The standard in, I'm trying to find the exact line right here under scaffolds, the exception. Scaffolds and materials may be closer to power lines than specified above, where such clearance is necessary for performance of work and only after the utility company or electrical system operator has been notified of the need to work closer and the utility company or electrical system operator has de-energized the lines, relocated the lines, or installed protective coverings to prevent accidental contact with the lines. So that's where in the OSHA standards, it addresses the insulation aspect. That's the only area that I can find where insulation is actually even mentioned. When you look at cranes and you look at heavy equipment operating near power lines, insulation isn't even an option. OSHA just says minimum 10 feet plus 4 inches for every, 10,000 volts over 50,000 or something, I think are the numbers. The perfect solution, de-energize the entire building. Not realistic. Secondary solution, possibly temporarily rerouting wiring and rerouting so that you can get the work done. The reality is sometimes insulation is the best you can do, and the general contractor is going to be the one responsible for making sure that his building, all you are is, let's say the painter. It's not your building, it's his building, that he renders it safe for his subcontractors to work with. That would be my best recommendation. And it is not an easy or a good answer. There's no magic, praying, okay, we're done. Planning phase is where this needs to be addressed.
Okay. Yeah. Now this comes up. It doesn't come up that often, and I didn't know if there was anything new, anything different about it. We have had them temporarily moved before, but that was rare. That was like 10 years ago. Some building owner of a commercial building did have them come out and they jumped the cables they jumped them to some other temporary telephone poles or something. But I know like we bid like these AMC theaters and they've got a lot of power coming in the back and those theaters will not let you turn them off. Otherwise they're not selling tickets. So, and we haven't bid those in a while, but that's what made me think of this today to try to head it off at the pass of, choose not to bid them. Tell them up front when we're bidding them, hey, we'll be happy to paint that back of the building, but you have to have it de-energized.
John, do you guys have a forum at all where, you guys can share stories and, hey, this has worked for me before, an FAQ type situation where the FCA members can ask questions like this and say, hey, what have you done in the past? How have you addressed this?
Well, ideally, this would be the forum, but other than that, I mean, it's just, no, it's this. This is the safety community call where you either, we come here for a topic, and if anybody has any questions, whether it's related to this topic or anything else, that's the time to bring those questions up and share. Ideally, just something we want to continue to build, but this would be our forum for that.
Yeah.
Yeah, I've been actually meaning to call OSHA just to ask them. And a lot of times and I haven't done that in a while for something like this. I mean, a lot of times they'll send you some information, some standard, but I have not called on this one. And I've been meaning to.
Yeah, why don't you let us do that? That's what we're here for. Put my pen away. Imagine that. Power lines at buildings.
And the building owner cannot shut it off because they just can't. It's a printing company that runs 24/7 or something. So what does the contractor do if he has to encroach within 10 feet to do the work? We get ComEd to insulate them. They'll do that. But is that good enough then if we give the guy non-conductive tools? That's what we have done, but it's been years. That's what we have done. And I almost don't like it because we train our employees on like what we're talking about today. And then it's like, okay, well, you are going to be working within 10 feet of power lines and here. So we're going to attack it as safe as we can now. So
Yeah.
it's just kind of, I was trying to find a definitive answer one day, and I wasn't expecting you to have it. It's just, I can't find a definitive answer saying, here's exactly how you do it when you can't de-energize.
Yeah, I will contact OSHA and find out. I'll get back to John Lee, and then he can get back to you. Or why don't you do this? Put your request in an email to the FCA helpline, and that
Sure.
way it'll come to me, and I'll have your contact information. And but I will tell you that OSHA has a tendency to be way hands off on telling the experts how to do their job.
Yep.
They just tell you what you can and cannot do. And
No, I
often they
know.
will expect you to come up with a solution, and then they will address
Yeah.
your solution to see if it's in violation of any standards.
Yeah.
And so that's been my experience there. But let me look into it.
Yeah.
I'll see if any of our clients have any ideas too.
Yeah. I got to ask our broker too. Again, this came up today. I was thinking about it because of the topic, and it's not on the forefront of my mind until you run into it. So, and
Yeah.
I'm not, believe me, I'm not out here to try to stump anybody. This has just been an
Stump the system.
ongoing, it's been
Yeah.
an ongoing thing for years, and we run into it once every couple years.
Well, if you have the question, somebody else does as well. So appreciate you
Yeah.
asking it.
Yeah.
And you
Okay.
have
Thank
the
you.
you have the helpline email, safety helpline.
Not in the top of my head, but I know I asked a question 10
Yeah.
years ago on it, but what is it? I'll take it.
Yeah. It's safety helpline at finishingcontractors.org.
Okay, I got it. I appreciate it.
Hang on, I see some chats here. All right, so iPhone 31 wants the PowerPoint. Yes, same email, because I don't know who iPhone 31 is. Send me a
I got her.
request. I'll send you the PowerPoint. I'll also send it to John Lee in a PDF, and he'll have it. It will be posted eventually on the FCA YouTube channel. Are you already addressed that, John? Okay, so Peter.
All good. No, appreciate you looking at it though.
Yeah, no, it looks like all of the questions. Beth, I assume you have the same question?
Yep, I got her email as well, so I'll send that presentation out as well.
Perfect. And we'll get that out to you. We just need to PDF it and send it out.
Perfect.
Sounds good.
Any other
Great.
questions from anyone? Now's the time.
2 minutes.
Well, and again, if a question comes to you after the call, safety helpline at finishingcontractors.org is your resource, or dial the number. So, or FCA at finishingcontractors.org. We are here. This is your community. This is your resource as a member. So we are here to help in any way we can. So,
All right, you got it.
all right, wonderful. Alex, thank you. Rich, thank you so much for being on to help out. Another great topic, and always things to consider, whether they're learning new things or reminding you of things. Great topic though. So thank you for that. Thank you for participating, everyone. And we will have another call in April. So look out for that. We'll send out the notifications for that, and have a safe month.